Good morning or good afternoon, everyone, depending on where you're joining us from, and welcome to today's webinar. My name is Garrett from Business Review, and I will be your host today. It is our pleasure to have Donaldson with us today, who will be presenting this webinar titled, Why Vent? Learn how to help protect your battery pack with dual-stage venting. Today's guest speakers are Jake Sanders, Engineering Manager, and Johan Begin, Sales Manager. But now, please allow me to welcome Jake Sanders.
Thank you, Garrett, for the introduction, and thank you to the attendees for taking the time to visit our webinar today. We appreciate your time and your interest in Donaldson. The subject of our discussion today is, well, why vent? What is venting? And today we are going to learn how to help protect your battery pack with dual-stage venting. First, an overview of the presentation. First, we will discuss venting in a general sense, discuss what venting is for enclosures. Then we will focus on dual-stage venting for electric vehicle battery packs. And we'll finish up with a little bit of information about Donaldson and a question and answer session. So first, we're going to just discuss venting in a general sense. Why do we vent enclosures? The purpose of venting is to equalize pressure in an enclosure to protect the seals and gaskets of the unit. Any enclosure in a vehicle, whether it's an ECU, a battery pack, a powertrain, consists of an enclosure which protects internal components, and the pressure between the enclosure's inside and the outside world could change over time. For example, if the temperature is decreasing in the enclosure, that will tend to create a vacuum condition in the enclosure, and in this situation, a vent can allow air to flow in. If the temperature of an enclosure is increasing, this can cause an overpressure within the enclosure, and a vent can allow air to flow out. What's important is that while air is coming in and out of the enclosure to equalize pressure, that we keep water, dust, and contaminants out of the enclosure and maintain integrity of the vent over time. The images on this slide indicate a very basic illustration of how this is important. So on the left-hand side, we see an enclosure which has a body, an O-ring, and a cover piece. And in normal pressures, when the pressure inside and outside is at equilibrium, the cover and the O-ring and the enclosure maintain their seal without deflection. On the right side is an exaggerated image showing a vacuum condition inside the enclosure. If that enclosure is not adequately vented, a vacuum could build inside, which could cause some deflection of the cover, which may create a leak path between the cover, the O-ring, and the enclosure. On this slide, we will discuss a core technology used in venting, Tetra Tech's expanded PTFE membrane filter media. This is an ideal material for venting. Tetra Tech's ePTFE is a PTFE film, a Teflon. This material starts as an impermeable material, and it undergoes manufacturing processes to open up pores within the material. On the right hand of the screen is an SEM image of PTFE at 4,000 times magnification. The pores in this membrane are less than 1 micron in length. And what you are seeing is only the surface of the membrane. A typical membrane may have 20 to 40 layers of these fibrils and pores. This allows gas to permeate through the membrane, but it prevents water and other contaminants. On the left, we have several markets that this membrane is utilized in: industrial filtration, syringe, microfiltration, membrane distillation, and our focus for today, automotive. This slide gives an overview of venting in automotive applications. Venting is used all across the vehicle, typically using expanded PTFE membrane. The various applications include, but are not limited to, automotive sensors, lighting, horns, electronics such as ECUs, motors and pumps, hybrid and electric vehicle battery pack, powertrain, and fluid reservoirs, which include depth tanks, washer fluid tanks, etc. On the right-hand side of the screen are images of just several common vents that are used in vehicles today. In the next section, we're going to focus on dual-stage venting for electric vehicle battery packs. So everything so far in the presentation applies in this section, and we'll also discuss some of the unique needs for electric vehicle battery pack venting. Lithium-ion batteries are typically used to power electric and hybrid vehicles. Lithium batteries are arguably the most important storage device available today on the market. The electrification trend is growing and growing in automotive, and there is a lot of research and development around building better and better battery packs for the vehicle. Because of this, venting is a very important consideration in the automotive sector right now. The venting is used, as discussed previously, to equalize the pressure. Battery pack enclosures are very large, and even small pressures can create a tremendous amount of force on the cover and the enclosure. These pressure differentials can cause seal failure of the enclosure and even deformation of the enclosure. Enclosures are built to be lightweight to help with economy and mileage, and venting that enclosure can relieve the stresses that could be caused by pressure differentials due to change in altitude or change in temperature. The image on below is just an illustration of a typical battery pack enclosure. There will be a rigid enclosure that contains all of the cells and modules, wires, cooling, and other components and electronics within the pack, and then a venting solution which allows that pack to breathe and equalize differential pressures. There is a unique situation for electric vehicle battery packs as it comes to venting. This is thermal runaway or rapid degas of the cells within the enclosure. Thermal runaway can cause a rapid release of gas and an increase in temperature in the pack. Expanded PTFE membrane is too restrictive to allow these pressures to escape via passive venting. Additional pressure relief function is necessary for these events, which we call active venting. In this illustration on the left, we see in a thermal runaway event, the pressure is rapidly rising. The membrane is stretching, and then in the right, we see the membrane can burst and allow those gases to quickly escape. Donaldson's solution to this problem is the Donaldson dual-stage battery vent. On the left is an image of the vent itself, and on the right is a balloon schematic of the vent. Explaining the balloon schematic on the right, I'll start at the bottom and work my way up. At the bottom, there is a silicone O-ring to seal the vent body to the enclosure. Next is the vent body itself. Shown in blue is the expanded PTFE membrane, which is bonded to the vent body. And on the top, there's a cover, which protects the membrane during normal use, but includes pin features, which during very high pressure situations, which only arise in a thermal event, this membrane stretches into the pins and bursts, which can allow the gases to rapidly escape. Next, we'll show a video of membrane bursting taken with high-speed camera. This video does not show the actual vent, but instead a test fixture. This fixture was chosen to make the bursting more visible and easily seen in the video. As we can see, the pressure is rapidly rising. The membrane begins to deflect and burst on the cutting features. This is occurring at around 300 millibar of overpressure. This slide shows an illustration and a graph which is meant to help explain what is happening in the battery pack. On the vertical axis, we have the pressure in millibar, and on the horizontal axis, we have time in seconds. This graph is showing a 10 seconds of thermal runaway event. At 0 seconds, we have equilibrium pressure. And allow me to also explain the different lines on this graph. There is a horizontal line at 1500 millibar in orange, which is used to depict the rupture pressure of this enclosure. This is the pressure at which the enclosure would catastrophically fail. The cover would separate from the body, or some element of the enclosure would break, and the gases would come pouring out at that location. Lower, there is a yellow horizontal line at 300 millibar. This represents the pressure at which a dual-stage battery vent will burst and open. There is a diagonal blue line, which represents the pressure increase due to the thermal runaway. In this case, this blue line reaches 1500 millibar in only 5 seconds. If there was no active venting strategy in this pack, the pack would reach 1500 millibar in 5 seconds and rupture. Low in the graph, there is a gray line, which represents the active and passive battery vent solution. Initially, if the battery pack has a dual stage vent, initially the pressure will increase as the vent cannot pass the gases fast enough for a thermal event. However, at 300 millibar, the vent ruptures and allows gases to quickly escape. This keeps the overpressure of the enclosure much lower than the rupture pressure. It allows for the gases to escape early and begin diffusing over a greater period of time, and also allows for the gases to escape at a known and controlled location. At this point in the presentation, I would like to turn over the presentation to my colleague, Johan Begine. Thank you again to the attendees for your time and interest in Donaldson.
Thank you very much, Jake. As Jake indicated, my name is Johan Begine. I'm the sales manager for the EMEA region, based in the European headquarters in Leuven. Now, to start my part, I want to show you a video. Thank you very much for the product development and marketing team. We just finished this morning. First time showing this to the public. We are very excited. And this will give you a brief introduction of how we see a dual-stage battery venting. Good, great, thank you. I hope you all liked it. So we see 4 main functions for dual stage venting. First, seals and guards. The integrated sealing will protect against water and dust infiltration. That's why a very strong sealing is really critical. And the Tetra Tech membrane we selected will give the most optimal protection against contaminants and harsh automotive fluids. Automotive fluids can be very aggressive, so a proper selection of protection membrane is very critical. Pressure equalization is definitely some experience we have built up in the AdBlue market. We are using these solutions already for many years. It's not new, it's something which is proven, and we have for that best-in-class membranes that we have in our portfolio. Now, by using big membrane, we will also help avoid potential the condensation, damp air to be expelled out of the battery pack. You know, so at the moment the battery pack will heal up, you have condensation in, and through the membrane, the damp can get out of the battery pack. And very important to have a proper mitigation so that the large amounts of gases So we see that really sometimes the amount of gas are pretty impressive, can be expelled in a very short time frame. A thermal event only lasts for a few seconds, but huge pressure and very high temperatures are created. Now we can consider the first three ones are really necessary in a daily way. We hope that the fourth function, the thermal event protection, will never happen, but it is there in case it's needed. Now, when you start working on venting and thermal event protection systems, there are several things that you have to take into consideration, technical stuff. Most optimal sealing is very important. Water and battery, that's a really dangerous combination. Under all circumstances, you want to warrant a perfect good sealing. Will the system give a fast and reliable pressure equalization when driving from warm to cold and driving rapidly down and up a mountain? Something we really have to think about. It has to do with the size of the membrane that you want to select. In case of a thermal event, you want to have the most optimal protection, so it's good to understand what needs to happen. The guidance that we can give you, we are not thermal event experts. We have built over the last year some experience, but something you have to think about is what will happen in case of thermal event. The easiness and speed of installation is important. Once you will go to full and high-speed volume production, maybe you think, yeah, it's less critical now because the volumes are still low, but they will grow. When we look to the forecast for the coming years, the EV market is growing rapidly, and for that, we have to take into account an easy installation. So you have to think about it right now, not once the product is in the market. How much free space do you have around the battery pack? We see that car manufacturers want to have as limited loss space, we call it, around the battery pack as possible, and for that you need to think about available height. Sometimes you'll be surprised how tight everything is packed, even in battery packs. So for that, you think about, okay, what is the best position to put it? Is the system you will elect, the system that you want to use, is it completely closed under all circumstances? So we see today in the market there are several systems, and which one do you want to use? A closed membrane, really sealed? Is that the way you want to go? And what is the, for your point of view, the most proper solution for that? When will it work under all circumstances? And every gram matters today. It will be important to add as less as possible weight. We have seen in several projects maximum weight indications. So sometimes you see, yeah, it doesn't matter how big and how heavy it is. No, it matters. It's very critical and very important to take this into account initially when you start developing your venting solution. Now, when you think about the venting, it starts all with the proper location. People often ask us, where do we need to put the vent? It depends. It depends on the size. It depends on the number of compartments that you have. It depends on what you feel is the best proper position to make sure in case of a thermal event, you have the best possible fluid of your gases, but also take into account the venting volume you need. So there are many criteria, and for that, it's a case by case. There is no one optimal guidance we can give you there. We can help you, we can support you, we can talk to you to find this really sweet spot, but it's really a case-by-case situation that we need to evaluate every time over and over again. Very important is think about the solution on time. Don't wait too long. We have seen in many cases that customers think, yeah, venting is not that critical, not important, we will wait for it. No, the moment you start developing a battery pack, immediately start thinking about a venting solution or emergency degassing solution. Now, there are several specifications for the solution that we can offer you. Today we have a bayonet quarter turn solution, and soon we will also have an M35 screw solution. The proven top part, it remains. That's something we have tested, we have validated. It remains the same, and only the connection interface will be different. A bayonet solution is ideal if you have a thin wall, for example, with sheet metal. For threaded parts, you need more material to warrant the proper connection strength over time. So yeah, for example, 0.7 thin walled metal sheet, we don't advise you to work with an M35, or you must work with a counter nut. In other case, we have very good experience with the bayonet quarter solution. Now, the Donaldson dual stage vent at a height of only 10 millimeters, so very limited space is needed. Normally, you have certainly somewhere around battery pack 10 millimeters, so we really developed it to keep it as thin as possible which was one of the main criteria when we started development. We have for the moment 3 different plate thicknesses. In the case of high volumes, we can definitely look at you case by case if we can modify this. But today we have already defined 3 most common, most used plate thicknesses and have these products available. There's an airflow which is pretty high, 100 liters per hour at 70 millibar. So will this mean that with one vent you can work on all battery packs? No, it's again the case by case. Maybe you need 1, some cases you need maybe 2 or 3, and that's also on us to help you to really work together with you to define how many vents you need. It's depending on the free air volume. We see free air volumes, for example, starting off 50 liters, but it can even go to much higher, to 150 liters and more. So it's really very important that you look at this together with your specialist, with us, to guide you, have better guidance on that. The opening pressure that we have in our dual stage venting solution is 300 plus minus 50 millibar. This is something which is defined together with market requirements, and we see also sometimes people asking for less pressure opening. We do believe that with the solution we have today in the actual design, this is the ideal opening pressure in combination with a closed system. It will give you the most optimal protection. Don't forget that the most important function of your battery vent is the venting, is the pressure equalization, something which is a daily need for, and that's something we have a high focus on. It must work every day and not only in case of the thermal event. And for the membrane, we use an oleophobic treated membrane, which is completely developed and manufactured in-house. We have 20 years plus experience, and that's why we have a very large portfolio. We selected one ideal, perfect membrane for this application, proven to be successful in the past. Now, there are several environmental tests. This is only a short view of the testing that we have done so far. Just to give you an indication, important one is the pressure equalization. We have done more than 60,000 cycles with a plus minus 50 millibar under and over pressure, just to prove the membrane will remain strong and stable over time. This is very important. It's not only when you get the component, membrane should be stable, but all after the long-term cycles, it should be as stable as the first day. This is very critical, and for that, the membrane selection is probably one of the most important parts when you start developing it. Temperature cycles are very important. It's a standard test in the automotive market. We have also conducted a pretty impressive one. And have you ever seen a thermal event? Now, our customers have conducted several bunker tests because it's something you can't just do in your facility. You need to have a special bunker for this. And I can guarantee you it's pretty impressive to see. As said before, it takes a little time, but the pressure and the temperature are extremely high, extremely powerful. So in case of a thermal event, I can guarantee you a proven, trustful solution is really important and needed. We have seen it. We have seen the outcome of the test, and it's really crazy. It's very impressive. So a reliable solution it's really something I can advise you. Now, the ease of assembly is also important. For that, we have tested intensively the installation. The engineering teams, they have really tested hundreds and hundreds of dual-stage vents. They have installed over and over again. They've done some tuning, improvement over and over again to make sure that it's an vent that you can install even by hand. It gives a very perfect, solid sealing and very easy installation. It's a quarter-term solution, so it's very easy to integrate and to use it. The quarter term is something definitely in the beginning of your battery pack production. There is no special tools needed, no expensive automations needed. So in the ramp up of your production, you can easily by hand do the assembly, and you have very confidence. It's a click, you hear a click, and these clicks will give you confidence that there's a perfect installation has been done. Now, our customers have conducted an on-road testing, and it was pretty impressive. They have drove around 30 kilometers with the car, and they does in the most dirty, most cold, most strange environment to make sure that the car is performing well. We have received, just before the COVID-19 situation, we have received some vents back in the offices. We have tested them, we have evaluated that, and we were pretty impressed. There was no water and dust and oil infiltration, very strong connection. The membrane and the plastic, they in perfect working condition, and the membrane, the welding was still 100% as less the factory. So that's what further confirmation that this is a very good solid solution. Quality assurance, we have in our organization 100% testing assembly line, meaning that every component which will be shipped to our customers, they are 100% tested, they're 100% validated prior to ship to our customers. So this is something we are proud of. This is something we really insist you to think about once you go to this solution. Now, there's also some general things to consider. Very important is, are you working with a local company or with a global player able to support you all over the globe? Do they really they convert the membrane themselves, or is just somebody just buy and convert, or do it as Donaldson have, a completely in-house development and manufacturing facility? What is the expertise level in the automotive? Are they EATF compliant? Are they used to work in the automotive environment? 100% tested and validated product. What is the confidence that once you receive the product, how confident can we be that it's 100% meeting requirements? Now, willingness to find the right venting solution for your need is we're not working with one standard solution. Today we have presented you this solution, but we continuously think about, we sit together with the customer. For example, we adapted, if you've seen with the bayonet water term, the plate thicknesses, and we are always looking for you for the most proper solution. We are also working with product development to future solutions. So we are definitely very important to talk to us, to take the time to spend with us, and really make sure that we take the time to listen to you and see if our solution is really meeting 100% your requirements. And for that, we will also be able to help you further. This continuous development improvements, we have a very capable product development team, and continuously there are discussions with sales, product development, product engineering. What are these market needs? What is the future vent? What do we need to develop? This is something very important when you think about the partner. Do they develop now one solution which will last for many years? Or is there willingness and continuously developing work ongoing? This is very important to make sure that we keep you support you further to the future. And it seems logic, but I do consider it's very important. Is it a solid and financial healthy partner you are working with? Now, who is Donaldson? Donaldson is a worldwide provider of filtration and systems and replacement parts. We are a $3 billion company, more than 14,000 people, and more than 44 manufacturing locations worldwide. And we consider ourselves as a technology and customer-driven company. Donaldson is very active in many markets. It will take too much time to go over all these markets, but what the most important is that the links between all of them. We take sometimes technology used in other departments. We have core tech teams which bring knowledge from one department to another. For example, we developed a completely new powertrain vent, which is in collaboration with other departments. They bring us unique technology, and that's what makes Donaldson unique. Is the way we collaborate, the way we take experiences and knowledge from other departments. We bring this together in unique products. For example, a venting solution that you see on your corner in the right is initially coming from the disc drive business. Disc drive working for more than 20 years with membrane. So we have a long-term experience, and we looked at new applications. We looked at other application markets, and this is why venting solution was created. So we don't invent something in short notice. It's many years experience we take with that. You know, why is Donaldson the ideal venting partner? There are in our pillars 3 important pillars. The integrated solution, as you see, today we didn't only talk about the membrane, but also the plastic part, the O-ring, the integration of everything. We bring all these components together, and we supply you a finished component, a component that you can immediately use in your production. You don't have to start developing subcomponents. We bring things together. We weld the membrane, we supply you in blister trays, make sure it's supplied in the most proper way to your production facilities. The advanced technology is very important. This is something we are very proud of. We continuously keep investing in this, make sure we have a state-of-the-art technology. And this is one of the pillars, very important pillar in our department. And except for global support, we are also in venting solutions. We are everywhere in the world. So we have our headquarters in Europe, we are in Minneapolis, we are in APAC. So we can serve you, we can support you, we can help your project all over the globe. Not only from sales, also from engineering side. So we all make sure that technical experts are always very close to you. Now, thank you very much for your time. Hope many interesting questions will come. In case of questions, don't hesitate to reach out to me or to Jake. We also have a general email address. Looking forward to talk to you, work together with your teams. We really want to do this, and don't hesitate to reach out to us to help you. So thank you very much, and let's now move on to the question.
Thank you very much, Johan, and thank you, Jake. Just a reminder for the audience, in order to ask those questions, you can send them in via the questions widget. Just type them into the box at the top left-hand corner of your screen and click submit. We have some questions already for you, and that first question is, how many vents are required for a single battery pack? Any standard available for vent location identification?
Yeah, this is a great question. The sizing of the vent for a battery pack will depend mostly on how much free air volume is in the pack and what type of thermal runaway gas release is anticipated. We can work with our partners to model this and size this, but as a general number, we're typically looking at 2 vents for a full EV and 1 for a hybrid, but this can vary by application depending on the pack design and other specifics. I think there was, I apologize, Jared, what was the second part of that question?
So the second part of the question was, any standard available for vent location identification?
We do have installation guidelines that can be shared, and on the top of the pack or on the side are typical locations for the vent. It's important to protect the vent from flying debris, specifically in the environment.
Thank you very much. I have another question here for you. Can you share the details of the thermal runaway test shared on the environmental test example slide? In what way did the vent help during the event, and what were passing conditions?
Okay, yeah. So as Johan alluded to earlier, the actual thermal runaway tests are run by the clients at their facilities, typically in a bunker or some type of special space for thermal runaway testing. The way the vent helps is it allows the gases to release at around 300 millibar from a known location. A passing condition is that the pressure is monitored inside the pack during the test, and it is identified that the vent opens at the correct pressure and that it has enough size and capability to flow the gases out and keep the pressure low to allow the heat and gases and pressure to escape through the vent location. And these tests are run on new parts. They're also run on parts that have undergone the various vibration and thermal cycling and other environmental tests leading up to that to prove that the vent still functions after it encounters the harsh conditions.
The next question is, how large of a battery, in terms of volume, are your dual-stage vents designed to support?
This is a good question. So for passive venting, kind of the core function of the vent, the sizing comes down to how much free air is inside of the pack. The amount of air that exists between the modules, between the wires, how much air in there do we have to vent? Because as that air increases in temperature and expands, it's about the volume of air. To give a typical value, like I said earlier, a full EV, usually around 2 vents to service that, which might equate to somewhere around 5 gallons of free air volume. But that can vary depending on how tightly packed the battery pack is.
Yeah, it's a case-by-case situation. And we've seen free airs of 50 liters, 100 liters, 150 liters. Is it one big battery pack or a lot of small compartments? It's because we see that some projects are really looking at it, making a lot of small compartments with all separate ventings to make sure that if there's a thermal event, it only be isolated in one compartment. But we also see in some cases huge battery packs with huge free air volumes. So it's really something to look at case by case.
Thank you very much. The next question is, can you please share pressure difference caused by an altitude or temperature rise inside any reference battery pack? This would help in understanding the problem in more detail. I'm sure for thermal runaway we require venting, but regarding change in pressure inside, I'm a bit confused that it might not be a very big concern.
Okay, yeah, this is a great question. I do not have in this presentation slides which show this, but generally speaking, the altitude change or temperature change that you are looking at for a pack, it can be calculated just by calculating using the ideal gas law. What would the pressure be after a temperature change? And what I can say is that without venting, you could easily be seeing during typical altitude and temperature changes, pressures exceeding 50 millibar or 5 kPa. And then many packs are being designed to be lighter in weight. And so even at that level of pressure, that could be the equivalent of, I apologize for the English units for some of the audience, but on a full pack, that could be hundreds of pounds of force exerted on the enclosure wall, even in just simple altitude changes due to the size of the enclosure.
I have another question here for you. Do you see differing vent methodologies for hybrid versus full electric?
We do not. So the vents are venting is used for hybrid packs as well as full electric. One difference is that a hybrid pack is typically smaller, so one vent in that application. The main thing I would point out is a dual stage vent is more specific to lithium chemistries, which have the potential for the thermal events. In some hybrid applications, there may be other battery technologies still in use, and those could potentially use more simple venting with just membrane and not requiring the dual stage feature.
Thank you very much. Another question here. How is the dual stage system affected by temperature? Recognizing that PTFE has a melting temperature of 325 degrees Celsius, and a thermal runaway event can reach temperatures of 1,000 degrees Celsius at the source.
One thing to note here is the dual stage vent's purpose is to open at 300 millibar, plus or minus 50, and to allow the gases to escape at that point and beyond. If there is a significant thermal runaway event, this is going to result in the complete destruction of the battery pack, potentially additional damage to the vehicle. And at the temperatures that can be reached by a full thermal runaway, the vent will, during that process, melt and fall away from the enclosure. Through this process, it, of course, is allowing gases to escape. They will still escape through that orifice location throughout the event. The membrane itself will not actually see the high temperatures during a typical thermal runaway. The reason for this is that there is quite a bit of insulating air between the source of the runaway and the membrane itself. And because the pressures increase so rapidly that the membrane is deflecting and bursting much sooner than it is getting hot. But yes, in the event of a complete catastrophic thermal runaway, the vent would melt, I suppose, over time, and we've seen that in some of the testing.
Yeah, there's also a difference between the temperature at the battery once the thermal event is happening and the temperature we will reach at the position of the vent. We've seen that it's completely different. You will never get 1,000 degrees temperature at the position of the vent, but an interesting discussion is, okay, what is then the exact position? And that's, again, a case-by-case situation. We have seen in some cases a few hundred degrees, in some cases it's even a bit higher, but we will never reach identical same position at the battery vent than really thermal event location.
Thank you very much. So I have another question here for you. Is battery enclosure venting normally done directly out to environment, or is it directed to a specific area, almost like ICE exhaust piping?
We've seen different approaches. This is up to the pack manufacturer at some extent. Typically, it's the location of the venting in that event is considered. So if we are venting out of the top, what are the components directly near this vent? It can be vented directly to the environment, but we have also seen situations where this vent is releasing into a manifold or other system that further is directing the gas away from the location of the vent.
Thank you very much. Just a reminder for the audience, keep getting those questions into us. Just type them into the box at the top left-hand corner of your screen. The next question is, would the bursting of the vent create a walk-home event?
I believe the terminology, the walk-home event, is meaning would the vehicle be disabled at that point? Keeping in mind that the pressure required to burst the vent is caused by degassing of battery cells or thermal runaway. In this case, if it is a very limited event and the pack and the vehicle are designed to drive after that event to a service station, the vehicle could continue to be driven. Just keeping in mind that after the vent is burst, it is no longer IP67 capable. But in most situations and most people we've talked to, they're viewing the runaway event as a serviceable event, typically resulting in the replacement of the battery pack.
Thank you very much. The next question is this solution available for other vehicles or products that are considering moving to electrification, like off-road vehicles?
Yes, the vent would be suitable for really any large lithium battery pack enclosure. This could even include stationary enclosures, not just off-road or on-road vehicles.
Thank you very much. The next question is, what are the installation requirements for your vent?
So we do have installation guidelines which can be shared. There's nothing too unusual about our installation requirements. We need a clean flat surface to integrate with the O-ring, and we have specific dimensions and dimensional tolerances required for the snap or thread fitting.
But we share full details. One in going to discussion with our customers, we share full details and we guide our customers to make sure that the right installation guidelines are found.
Thank you very much. I have another question here. How much pressure would be required to blow away the vent membrane if it didn't have the dual stage piercing prongs for pressure release? If my system can withstand a pressure greater than PTFE membrane, do I actually need a dual stage system?
Okay, so the first part of this question, what pressure would be required to blow away the vent membrane without the piercing? This would vary by the selection of membrane. In the case of our vent, this would be in the couple thousand millibar range in the inside to out direction, so quite high. If the system can withstand a pressure greater than the PTFE membrane, do we actually need a dual stage system? So the membrane's burst pressure is designed to just keep the pressure inside of the system low during a thermal event. If there is a thermal event, there really is not a pack enclosure on the market that I'm aware of which could withstand the pressures that would be created. Something would burst or break. The pressure would relatively quickly reach hundreds of pounds per square inch because there is not only the temperature change of the enclosed system, which causes gas expansion, but also the creation and release of gas under the thermal runaway as the gases are burning or the liquids are burning inside the cells.
Thank you very much. Wonderful. The next question is, what is the difference between your vent version intended for sheet metal battery housings versus aluminium die-cast housings with higher housing thickness?
Yeah, this is a very good question. So Johan discussed the bayonet quarter turn fitting as well as the threaded fitting. I'll go into this briefly. The bayonet quarter turn can work with a sheet metal housing. simply by having the correct shape stamped or machined out of that sheet metal. The bayonet just has to be designed, or the sheet metal has to be the appropriate thickness to interface with the bayonet. This is suitable for very high volume manufacturing and low cost manufacturing of the hole itself. With a cast housing, the cast housing can also be machined to accept the bayonet fitting. So just machined to having the proper thickness and orifice opening. Additionally, a cast housing, if it is thick enough, could be machined to take the threads directly. And with a threaded battery vent, a nut could be additionally attached to the inside of the pack, even in a sheet metal application or cast aluminum if it's relatively thin. And so really both the bayonet and the threaded versions are suitable for both stamped and die cast, but the details of how to get there could vary slightly between those applications.
Thank you very much. I have another question here for you. How many vents required in one battery pack, and how can we calculate?
Oh, yeah. So this is similar to an earlier question, but I think it is an important one we can discuss again. The calculation of this is something that Donaldson can certainly help with. What we need to look at is how much air volume inside, what do the temperature changes look like, how rapid are the temperature changes, and also the altitude change scenario. Oftentimes in the U.S., we're looking at the Pikes Peak test, where you consider what if a vehicle is driven from the bottom, from the base up to the summit of Pikes Peak in a certain amount of time, and vice versa from the summit to the base. We can actually calculate the pressure change and venting required for that altitude rate of change and the amount of volume inside the pack. That is for passive venting. For active venting, we do need to have some help from the pack and cell manufacturers to understand how much gas do they need to vent and over what period of time. And then we can calculate the vent's capability to do that. Typically looking at 2 or more vents for a full EV, and for a hybrid, typically 1, at least per pack. A minimum of 1 per pack, more for larger packs.
Thank you. The next question is your dual stage vent on road / in production?
Yes, it's fully in production.
It is. Oh,
yep. Sorry, Jake. No, it's only in production. Really, it's a production equipment and production inspection method. So with camera inspection, 100% airflow measurement, make sure that every component, the cover, everything is on, the O-ring is in. There are special blister trace made, so everything in production. I can't give you names, but there are today EV cars in Europe from very big automotive players driving around with the Donaldson dual stage vents for a while. So it is in production.
The next question is, what are the best locations for placing a vent on a battery pack and why?
Yeah, the best locations are on the top or on the side of the enclosure. We want to avoid locating the vent on the bottom of the enclosure. The bottom of the enclosure is more exposed to flying debris and other mechanical impacts. And if there were ever a situation where some water were to condense inside the pack or some fluids would leak, they could potentially, like such as coolant fluid, there's the potential that fluid could flow to the lowest point of the enclosure, and if that is the vent, it could block the vent. So we really like to avoid the bottom of the pack. That's the critical thing around location.
Yeah, we see today we have applications where the vent is on the top of the pack. We see also some applications on the side, but then often an aluminium tube is used to guide it, because you don't want to get your passenger in contact with hot gases. Sometimes you also see it on the back. It's really case by case, depending on position, depending on size of battery pack. There are so many elements taken into account that we can't say this is the way to do it. This is a proper location. It's often the the development team to decide and to work together with us, and we will give advice. But at the end, it's really depending on the shape and on the position of the car.
Thank you very much, guys, and that just leaves me to thank the audience as well. If you didn't get your questions answered today, they will be available to be answered at a later date. So that just leaves me again to thank Jake and Johan for it was a great presentation, and to Donaldson for sponsoring this session.